Hello, it's Carter Collin. We're running homework number one. In the first problem, you have a heat source that's between two walls, and it wants you to find the thermal conductivity coefficient K. In order to find that, you're going to use the thermal conductivity formula, and for that, it's going to have Q equals Ka surface area times the temperature gradient. And in this case, they give you the Q, the area of the surface, and then they also give you the temperature gradient, which is going to be the temperature of the surface of the wall touching the heat minus the temperature of the surrounding wood, and then you can divide that by the thickness of the wall, which is 0.5 centimeters. And from there, you're just going to solve for the K. The next problem, you have a fluid flowing in a pipe, and that pipe, it's going to ask you to find the heat transfer. And then from there, all you're going to do is it gives you a K, it gives you the surface area based off of the diameter, you can find the surface area from that, and then the temperature gradient is going to be the inside temperature minus the outside temperature. From there, it gives you a heat transfer, and for there, it wants you to find the amount of money lost. And to do that, you're going to multiply the heat loss by the number of hours in a year. And then you're going to multiply it by the price per heat, which they give you is $1.1 divided by 100,000 BTU. From there, you get the actual cost per year of the heat lost. Next, you're going to have the sun radiating heat onto a surface, which then reflects it, and it wants you to find this temperature of the surface. For that, you're going to set the heat radiated by the surface by um, uh, the heat absorbed by the surface from the sun. And then we also know that based off of the alpha, that the alpha times the heat of the actual sun is going to be equal to the amount of heat absorbed. And you set that equal to the radiation formula given off by the surface. And from there, you're going to solve for the surface temperature. And from there, you'll get this formula, and that'll give you the final answer. All right, for the final problem, it wants you to find the uh, binary diffusion coefficient. And for the first one, you just look that up in table 14-1 at 1 ATM and 200 K. And then for the next problem, you're going to take the same you're going to find the thermal diffusion coefficient at the same temperature, and then divide by the pressure that we want, which in this case is 0.5 atm. So you take it at 1 atm divided by 0.5 atm, and you find the original value from table 14-1. And then finally, you do the same thing, but at 600 degrees Kelvin for the last problem, and divide by 5 atm, and that'll give you a final answer. Thank you.